Some of the biggest quality wins in training a large language model come from the least glamorous step imaginable. Before a single parameter is ever trained, someone has to clean the data. And one of the highest leverage moves in that whole cleanup is removing repeated and near duplicate text from the corpus. Today we're breaking down data deduplication, why the same article showing up 1,000 times quietly hurts your model, and how teams actually find and drop all those copies at scale. Let's start with the core contrast because it makes the whole point obvious right away. Picture training straight on raw, scraped data. The open web is absolutely full of repetition. The same article gets reposted across dozens of sites. Boilerplate repeats endlessly, pages get mirrored, and templates look nearly identical. Feed all of that in, and you waste a ton of compute. And worse, the model starts memorizing those duplicated passages word for word, which hurts generalization and raises real privacy and copyright risk. Now picture training on deduplicated data instead. You keep one clean copy of each thing and simply drop the rest. The result is a corpus that is smaller, cleaner, and much better balanced. The model memorizes far less, generalizes noticeably better, and you also get cleaner evaluation because far less of your test set has quietly leaked into the training data through duplicates. So how do you actually strip all those duplicates out? The process runs in 4 stages. Starting out, you gather the raw corpus. This is everything you scraped, warts and all, packed with reposts, mirrors, and templated boilerplate. At this point, you genuinely have no idea how much of it is quietly redundant, and that hidden redundancy is exactly what we're about to hunt down. Then you hash the documents to find exact duplicates. When 2 documents or substrings are byte for byte identical, a simple hash catches them instantly and very cheaply. That removes all the obvious copies right up front before you spend any real effort on the subtler cases that come next. Next comes the harder case, the near duplicates. 2 documents can be enormously similar without being exactly identical. To catch those at scale, teams reach for min-hash and locality-sensitive hashing, which efficiently flag pairs that overlap heavily even across many millions of documents, without comparing everything to everything. Finally, you drop the duplicates and keep just one clean copy of each. What survives is a leaner corpus where every passage earns its place, and the overall distribution isn't skewed toward whatever text happened to be repeated the most across the messy raw web. There are really 3 ideas that carry this whole practice, and they're each worth remembering. The core action is removing both exact and near duplicate text. Exact copies fall to hashing, and the fuzzier near copies fall to min-hash. You genuinely want both, because most of the hidden waste actually lives in the near duplicates, not the byte-identical ones. Doing this cuts memorization and wasted compute together. Research titled Deduplicating Training Data Makes Language Models Better showed memorization dropping several times over, along with lower privacy and copyright risk, all from a step that costs almost nothing to run. And the payoff is better quality from less data. A deduplicated corpus let a model reach the same or even better results with less total training, which is precisely why this quiet, unglamorous step ends up being such a major lever. Okay, let's lock in the essentials, 4 of them worth holding on to here. Data deduplication removes repeated and near duplicate text from a training corpus before the model ever gets to see it. It comes in 2 flavors: exact removal by hashing, and near duplicate removal using min-hash and locality-sensitive hashing at real scale. The payoff is very real. Less memorization, less wasted compute, cleaner evaluation, and better generalization, all from a smaller corpus. It's quiet, but it's genuinely one of the highest leverage data steps there is. For more of these behind-the-scenes AI explainers, come find us over at Standarity.com.